Hello, welcome to the channel. And today we are going to be discussing the chapter named Units and Measurements, a class 11 NCERT syllabus. So let's get started. So first of all, we will go through what is units. Unit is a term used to specify any measurement, like as a first point, a measurement of any physical quantity. For example, we say, what is the body of weight? Uh, what is the weight of a person? 10 kg. In that, a kg is referred as a unit. Kg refers to unit. Similarly, a measurement of a distance like 10 centimeter, 10 meter, 10 kilometer, all those uh, alphabetical words at the end is referred to as unit. Means a significance of a number like 10 centimeter. Centimeter refers to the unit. So, what is unit means measurement of any physical quantity, and these are the units in physics which should be acceptable all over the world. Means internationally accepted reference standard. Units are accepted all over, and we should use those units in anywhere in the world. So there are a lot of examples. If you want to take examples, like just some basic examples like meter, m, and time, that is seconds, and next kg, that is weight. So now next go to the fundamental units. We can represent all physical quantities by using a certain units. Those are called fundamental. See, by the name itself, fundamental, you might have come across fundamental. Means fundamental means very basics. These are the necessary that units we need in physics to refer dimensions of any physical quantity. What are those? We will come across later in the later. So these are the fundamental units. So basically, what fundamental units means, we use these fundamental units to represent, to derive any unit, means to derive unit of other any other physical quantities. So in international level, there are a lot of a system, like system in the sense there are a lot of various ways we can represent a SI unit. So basically, there are like two, three divisions like CGS and FPS and MKS. So what does this mean? In CGS system, C stands for centimeter, and G stands for gram, and A stands for seconds. So these are all basically a distance measurements and weight measurements and time measurements. If the distance is measured in terms of centimeter and weight gram and time seconds, then it refers to CG system. And similarly, FES system. FEM system actually it's for French system. We can also call French system. In French country, they use a foot pound second, where foot is used to measure distance, and pound is used to measure the weight. Seconds is used to measure the time. Similarly, an MK system where we use kilometer to measure the distance and kilograms to measure the weight. Seconds, all three cases are same. So then, what is SI unit? SI unit is important basic terms we will going to use in the future in going through this chapter. SI unit is basically SI. The full form of the SI comes from French words, systeme and intermatimele. So you don't need to worry about that. Lot of it's just a name called international system of units. In other words, so just remember SI unit. Just instead of unit, just remember as a SI unit because it is internationally accepted. So next, now we have studied already fundamental units. What are the fundamental units? Means we need those units to uh, derive units of all other physical quantities, right? So let's come across seven basics fundamental units, and these three are the most basics. We use lot these three: length, mass, and time. We need everywhere here. And let's get started of all these three study. Like length, we usually measure in meter. We can measure in kilometer, everything, but just consider here as a meter. And SI unit will be m. And mass will be kilogram, kg, and time will be seconds, and that's SI unit will be yes. And the fourth one, electric current, which you might be studying in the future, ampere. and which is denoted by A. And the temperature, as you always know, you can measure in terms of Kelvin and degree Celsius and Fahrenheit also. But here we are taking Kelvin. This symbol will be K. If you take a Celsius, it will be C, of course. But we are taking considering one. Amount of a substance in the sense atomic weight of any element, that will be measured in terms of mole, and the symbol will be MOL. And intensity, luminosity, then luminosity intensity, just intensity, it will be in terms of candela. And CD, we can also write express CD in terms of all these first three: length, mass, and time. See, these three are the most basics, fundamental units which we are going to use a lot in the next study. And now let's move on to the next topic, measurement of a large distance. We usually measure distance using any scale, right? Generally, we use in classroom materials just like scale, any tailoring materials, a tape to measure distance. So, what we have to do when you have to measure a large distances? So, here is some new word like called parallax method. What is this method? We use this method to calculate a large distances, just like a distance of a star from the Earth, the distance of a sun from the Earth. So, what is this all method about? So let us understand this topic by considering an simple uh, real life example. Let us consider a person. Person is observing a star, considering a star here, and take a pencil in between this and close the entire star in front of your eyes. Now try closing your one of eyes. The pencil will look like it is shifted and other side. And if you try again with closing other eye, the pencil will look like shifted here, and star appears to be sitting over somewhere here, and these two same. So this is the experiment. So the distance between these two imaginary points, these two, which is got by doing experiment, is called basis. Basis. We call this one as basis. This is the term in parallax method. We use this one as basis. So this is a parallax method. So observing a star between two things. So what we are going to do in this method? So this concept we use here in this example. Let's take a star or a sun here on this, and let's take 2 points on the Earth, A and B. So since the distance between sun and Earth is so large distance, so B will be comparatively smaller than the D, and I'm sure uh, distance from A to sun and B to sun will be close enough and same. So this will be considered as D. And we know in the circle, like we use arc length the formula, S is equals to r theta, if r is radius and theta is a angle made between two radians, and S is arc length. If you use this formula over here, r is equal to S by theta, we get d is equals to b by theta. Means if we know the b value, means distance between the two objects on the Earth, and the angle made by the sun to the uh, point A and point B, we can calculate distance d, means the distance between stars to A. So this is how we measure a large distances. So what about small distances? For measuring of a small distances, we have a certain instruments like pre-made instruments like a screw gauge and vernier calipers. These measures uh, at least, means yes, we need a small distance, right? Small measurements, small length measurement. So screw gauge can measure 0.001 millimeter, and vernier caliper can measure 0.01 millimeter. So these are the instruments we use to measure small distances. Then next, moving on to the next topic, range of lengths means how much range we can see. Range means from what point to what point we have seen over the universe in the real life. So let's get here. Generally, femto in the sense 10 power minus and 15 meter. Femto. So we have atomic size of the order of femto, like atomic radius. Generally, atomic radius. it will be of the order 10 power minus 15, and nuclear radius also in the same order. So we can see minimum of distance is that one, and maximum is just whatever universe present we see universe, that is 10 power minus 6 124 meter long. That is the highest measurement we can do, right? Means we can do logically in realistic way. So similarly, if you ask for a range of lengths for the mass, we all done this from here to here about the length. So if you consider for the mass, a measurement of mass is just a measurement of a weight, measurement of a body, amount of substance in a body, right? We all know how to measure a mass. So if you ask for the range of the mass, and it comes from 10 to the power minus 30 kg, which is mass of electron. 2, it can vary up to 10 power plus 55 kg, which is mass of universe, which is expected, which is done by scientists and observed to be, it is to be 10 power 55 kg. And similarly, the range of time. So before going to the range of time, let's take understand what is time. Like time, what is 1 second here? How time is defined? Like say 1 second. See, the scientists have made if a cesium atom, cesium 133, this atom makes the given number. I have written the number which is given copied from the NCERT. If this make this much of revolutions per second, this much of vibrations, that that time interval is considered as 1 second. Cesium atom making this much of vibrations, that time interval which is considered as 1 second. So how much least can we go and how much maximum can have we gone, uh, is time measurement 10 power minus 4. This is the minimum time which a particle can stay in a particular state. So unstable particle can stay, uh, if you ask how much time a unstable particle can stay in the same state, that is 10 power minus 24 seconds. To maximum, like just take the universe, right? Lifespan of the universe, like when we all just started, life started, universe started, big bang theory, all those things we consider, that is as a biggest time, 10 power minus 17 order. It will be increasing, of course, as we move on, it will be keep on increasing, but at an average it will be of the order at an approximate 10 power 17. Now, after all these measurements, how to measure a length we have seen, and how to measure mass and ranges of those, all those things. So then the next term we go through is errors. Error in the sense, in English we know that the meaning of error means a mistake, or the, what we say, a difference which comes by mistake, that's called error. So there are a lot of different types of error in systematic way. In systematic errors there are different systematic errors. Let's go through one by one. Instrument errors. What does instrument error? By the name itself, errors caused by instrument, right? Like say we are measuring a radius, circle radius. If we use, we use different instruments which can be a defective, right? We can use defective instrument so that it can give once 4.1 centimeter, 4.2 centimeter, maybe the actual radius would be 4. So there we can see the errors, right? Like instead of 4 we are getting 4.1, 4.2. So which is the errors caused by the instrument, the type of instrument we use. So that is called instrument error. And experimental technique in the sense the person how he uses to measure the radius. uh, some might be doing from here to here, some might be calculating from here to here. So it depends on that, some might be doing from here to here. These are also called as radius, right? In experimental technique, there might be error. So if there is an error, those type of errors will be generally called as experimental technique errors. And personal error, personal in the sense it depends on the individual, the person who is doing the experiments, which is basically like he might be, if you take a scale, he might be starting from here, from 1 centimeter to 1 centimeter, or he might be starting from 2. Let's start from here. So he might be starting from here. So it depends, the mistakes made by the person or individual, that is referred to as personal errors. And these things, a random error means is just unexpected errors. We can just call it as unexpected errors. Unexpected, we can just refer as unexpected errors. Means we won't be expecting this can be occurs due to environmental effect. See, let's say if you want to measure a patient's temperature, which can be varied through outside environment, everything, right? So you can read more about this NCERT textbook, which is given very nice. Some examples are given, you can go through that one. So random error in the sense, it's unexpected errors which can be due to the external environment, which can be due to the external environment. Next, a least count error. Least count. What is least count? We already studied in the previous class that a screw gauge, instrument which is we use to measure small distances, that is screw gauge, which has a least count of 0.01, 0.01 mm. So what does least count means? The least value that instrument can measure. That is the meaning of least count. Okay. Similarly, the examples we have given examples: screw gauge which can measure 0.01 mm and vernier caliper 0.01 mm. Then absolute error. What is absolute error? Absolute error in the sense difference between the true value and the measurement value. So that is absolute error. And if you consider a relative error, if you want example for absolute error, just to consider if the radius of a circle is 4 and you have measured it is observed to be 4.5, the difference between 4.5 and 4 is 0.5, that is 0.5 is an absolute error. So relative error, the ratio of the mean absolute error. Mean absolute means average absolute errors. Let's say a student in a classroom, a student 1 measures 4.5 and student 2 measures 5, student 3 measures 4.1. So there is clear cut errors, right? Absolute errors between in every students. So let's take there are two errors which is 0.1 and 0.2. If we take average, 0.1 plus 0.2 by 2, that is 0.15, to the, see, the ratio of mean absolute errors to the value mean, okay, to the original value, which that is 4. So if we calculate this one using, you will get what is relative error. So means which is relative to the original value. What is that is what relative error means. And the percentage error, which you have to just take the percentage error of this. If you want to calculate it separately, again I can just show here, 0.14 divided by 4 into 100, which can give you a percentage error. Next, error of sum or difference. So how do we calculate errors in addition, subtraction? Let's take example of addition. Z is equals to a plus b. So we have errors in each terms. In z, let's take as delta z. Let's denote as delta z. Delta a, delta b are the three errors in three variables z and b and a and b. Okay, then let's get through the equations. Like we have moved across to the next stage where z is becoming z plus delta z, and a is becoming a plus delta a, and b is becoming similarly b plus delta b. So we are here interchanging these a and b, we get a plus b here, and delta a delta b. So here a plus b is delta z, so a plus b and z cancels out, the z and a plus b cancels out, so remaining is delta z is equals to delta a plus delta b. So this is the error. Means if you want error in the z, you just need to add error in the a and error in the b. Similarly for subtraction is the same. If you want error in the z, if you just to add a minus b. So if the equation is z is equals to a minus b, then the answer would be, the error in the z would be delta a minus delta b. Next, error of the product or coefficient. Z is equals, let's take the product, Z is equals to AB. Similarly, in the as we seen earlier, delta Z and delta A, delta B are the errors in these three variables. If you continue that equation, Z plus delta, just if you use A plus B multiplications, A into B, AB, and A into delta B, all this multiplication, if you multiply, and we get these equations, and if you divide by z this equation, z plus delta z is equals to this equation, Z by Z gives 1 and delta Z by Z, which is same. And AB, AB is Z, right? So AB by Z always gives 1. So similarly, A delta B divided by Z means AB, A cancels out, delta B by B. I have just written here and here, that doesn't make any difference. So delta B by B and delta A by A, and similarly the last term divided by AB. Divide Z to all the terms, okay? All the terms. So these one on one cancels. If you want a uh, maximum error in the sense, see, always we take error as a maximum value. We need maximum error because that's we are interested in calculating the error. What maximum error can we get? What is the error we can get? So we always try to find the maximum error. So here, adding these two terms, sometimes these two terms multiplication can give leads to 0 or negative, right? So only these terms can give the maximum value. So maximum error can be through delta A by A, delta EB by B. So similarly, if you consider Z is equals to A plus A by B, and if you do all this mathematics, and you will land up with the same equation. So finally, remember this equation, remember these two. If Z is equals to A plus or minus B, then delta Z is directly addition of error in the A and error in the B. And if Z is equals to AB or A by B, then the error is equals to delta A by A plus or uh, plus delta B by delta C. Okay, this is always plus because we need maximum error. We will never want it. We never need a minimum error. This is always be plus.